Hey guys, today we're going to take on some perilous probability. Hello and welcome to the Theories of Greezy. This video is just like my last video, only it's a completely different topic and you get to hear my voice. I'm not sure that's a good thing, but we'll roll with it. Today we'll be finding the probability of something in a game called WordScapes. If you aren't familiar with WordScapes, it's a game where they give you some random letters and you draw lines to make words and complete crosswords. There are 4,000 total crosswords in the game, which means that I have completed 5% of the game. Yes! This game even has enough words to satisfy your geeky friend who proofreads all of your essays. Heh, thanks Braden. Anyways, we are going to find the probability of finding a word whose letters directly follow each other in a clockwise or counterclockwise rotation immediately after scrambling the letters. Basically, you push a button and find a word that looks like part of a circle. I like to call them arc words, 'cause why not? We will be finding these in a 6-letter puzzle, so a 3, 4, 5, or 6-letter word will work. In order to do this, we must find the probability of finding a 3-letter word, 4-letter word, etc. individually and add them all up to find the total probability. We can do this because it just works.
Math is math. Math is math.
Don't question math, you can't do that.
Why would they change math?
Now, to find the probability for each type of word, let's start with 3 letters for example, we must divide all possible 3-letter combinations by all the ways you can get a 3-letter arc word. To find all possible 3-letter combinations, we'll be using permutations, since order matters in words. In this case, there would be 6p3 total combinations for 3-letter words, since we are choosing 3 letters from 6 letters. This means that there are also 6p4 combinations for 4-letter words, 6p5 for 5 letters, and 6p6 for 6 letters. The formula for permutations for NPR, for example, is n factorial over n minus r factorial. Now we can just plug the numbers in for 6p3 to get the total number of combinations for a 3-letter word. 6 factorial is equal to 720, 6 minus 3 is 3, 3 factorial is 6, which gives us a total of 120 possible 3-letter words we can make. Using the same method, we reach 360 4-letter combinations, 720 5-letter combinations, and also 720 6-letter combinations. It looks a bit weird with 720 combinations for both 5 and 6-letter words, but when you think about it, it makes a lot of sense. Each 5-letter word can be seen as a 6-letter word with the last letter cut out. However, 4 is not the same because in a 4-letter word, 2 letters are cut out, which could have been arranged 2 different ways in a 5-letter word, but gives the same result for a 4-letter word. Now that we have found all the possible combinations for each type of word, we now need to find how many arc words there are for each type. You can start from any of the 6 letters, and you can go clockwise or counterclockwise from each spot, making a total of 12 arc words for each number of letters. Now we put 12 over the total possible combinations for each type of word, add them up, and we're done, right?
Well, boys, it's gonna be ice cold sushi for breakfast. Pika.
Well, I say nay, old chap, we still got quite a ways to go.
Bummer.
By the way, if you didn't like my British accent, hit that subscribe button. Or you could check out my first video where I don't talk. If you did like it, you could join the notification squad, that's good too. Or if you're completely neutral about it, thought it was Australian, or really don't care, you could just hit the like button, or thumbs up, whatever it is. Anyways, we aren't done with the numerator yet. We need to multiply it by the average amount of each type of word in an average puzzle. For instance, if we go to puzzle 6, if we just put 12 over 120, that would be similar to the probability that you would find the word far as an arc word if there were 6 letters in this puzzle, of course. But what if we wanted to add in the probability of finding air as an arc word as well? There's a 10% chance of finding far and a 10% chance of finding air, which means that there is a 20% chance of finding either one of them. This means that to find any word in an average puzzle, we would have to multiply each fraction by the average number of its type of word. So I went through 96 freaking 6-letter levels for you guys, and made tally marks for all the 3 to 6 letter words in each level. It was awful. I only did 96 because I figured that in the next bunch of levels they probably wouldn't change that much stuff. Also, I hadn't really completed enough levels to do more. And I was sick of it. In these 96 levels, there were 369 3-letter words, 393 4-letter words, 148 5-letter words, and 108 6-letter words. Dividing all these by 96 gives us the average amount of words per puzzle, which is 3.844 3-letter words, 4.094 4-letter words, 1.542 5-letter words, and 1.125 6-letter words. Now that we have the averages, we can plug them into our fractions, which gives us a 1.75% chance of finding a 6-letter arc word, a 2.57% chance of finding a 5-letter arc word, a 13.647% chance of finding a 4-letter arc word, and a 38.44% chance of finding a 3-letter arc word. So many numbers. That's it, I'm done. That was too hard, I quit. Just kidding, I'll be fine in an hour. Oh, sorry. Just browsing over 100,000 digits of pi. Link in the description. Overall, adding up all these percentages gives us a 56.5317% chance of finding any length of arc word. However, doesn't this seem a bit high? Realistically, not all combinations of vowels and consonants will result in a word. For example, if one of the 12 combinations on a certain level is a group of 4 consonants, we can know that no word can be made from the group, and that possibility should be cut out from the possible combinations. But then again, that would take a lot of time and effort. I mean, come on, it can't be that important. Do you really want the answer?
Mr. President.
Mr. President, we need your final say.
You push too hard, darling, but I accept.
Wait, Mario, no! Don't do it, Mario! End your addiction to random plants and fungi. That flower could be poisonous. Mario, no! No! Mario, no! Wait, he's alive. Or is he? Alright, y'all should subscribe. That video took me quite a while. Also, make sure to watch my first video. It only took about a day to do the whole thing, but it's still pretty good. This one took like a month. Also, watch part 2. Coming to YouTube, spring of 2019. Hopefully not that long. Subscribe!